Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. Today's topic is characteristics of IoT. So the main characteristic of IoT is it's a dynamic and self-adapting. So it will be fit for the dynamic environments. It will be automatically adapt for that environment. Second, self-configuring. It configures itself for that required configurations. Interoperable communication protocols. So the different protocols, communication protocol available that can support this IoTs. Again, unique identity. So this is another characteristic of IoT. That means it have the unique identity feature in the devices. Again, integrated into the information network. So these are the basic characteristics of IoT. You can see the detail here. So first one, dynamic and self-adapting characteristics. So IoT device is a system. It may have the capability to change the dynamically depending on the system or operating conditions or sensed environmental or real-time requirements. So for example, the surveillance camera can change their modes based on the day or night. That is, if it is a day, automatically it changes the day mode. If it is a night, it automatically changes the night mode. So this will be dynamically adapt for that particular environment. Second one, self-configuring. So IoT device can self-configure capability which allows large number of devices to work together to prove certainty functionality. They can change their networking and update the software automatically. So it can update their software automatically. Similarly, it can configure itself without help of other devices or other softwares. So automatically it can configure it and it can update the requirements. Third one, interoperable communication protocols. So IoT device can communicate with a number of interoperable communication protocols. So it can communicate with other devices with the specific protocols. It supports so many wired and wireless protocols to communicate it. So wired protocols like I2C, SPI and CAN protocols. Similarly, wireless Wi-Fi, Bluetooth, other NFC, so many protocols that will be supports. Unique ID. So IoT device have an unique identity differentiated with the unique IP address. See, each PC we have the identification of IP address. Similarly, each IoT device we use this unique ID to identify that particular device, because millions of IoT devices will be connected in the internet. So to identify each device, we need to have the unique identity or a unique name for that. So that is called unique ID. And integrated into the information network. So IoT devices are integrated into the information network that allows them to communicate and exchange the data with other devices and the system. See, we are connecting all the devices through the internet. So we need to exchange the data and we need to transfer the data and we need to process the data. So it should be integrated of millions of devices. Even the devices are not close to them. It may be available anywhere in the world. So we need to integrate all the devices through the internet. So we use this cloud to store the information. So we use the internet to access the cloud. So whenever we have some data that should be stored in a cloud and that can be accessed by some other IoT devices to perform the required task. So next will be physical design of IoT. The thing in IoT usually refers for an IoT device which have an unique identities that can perform the remote sensing, activating and monitoring capabilities. So IoT, it may perform sensing. Sensing means getting the information from the sensors. Activating is activating the output devices. That is called activating. And third one, monitoring capabilities. Continuously it monitors the parameters in the real world signals. So IoT device can exchange data with other connected devices and applications and collect the data from other devices and process the data locally, or it may be required, we can perform it globally also. Send the data to the centralized server or a cloud-based applications and it performs some task locally and then sends that result to the IoT infrastructure. So based on our temporal and space constraints. So depending upon that application, we decided whether we are going to perform locally or a cloud-based computations. Generic block diagram for an IoT device. Look at this. So this is the connectivity. We have this USB port or a Ethernet, processor, So we can use this CPU. Audio video interfaces, HDMI 3.5 mm audio, RCA videos. IO interface means input output interfaces. It's like an input devices like a sensors and output devices like an activators. UART, that is a universal asynchronous receiver transmitter. SPI serial protocol interface. IIC, that is inter-integrated circuits. CAN protocols. So these are the protocols that will be used to communicate with that. Memory interfaces, so NAND NOR based memories are a DDRAM 1, 2, 3s, and graphics we use this graphical processor GPU, and storage interface that is SD, MMC or SD IOs. So an IoT device may consist of several interfaces for connection to other devices, both wired and wireless methods. So IO interface is used for sensors, interface with internet connectivity. So memory and storage interface that will be used for storage of informations, and audio video interface to interface the audio and video signals.